All right, happy Thursday morning. A little bit warmer out today, so I hope you're enjoying yourself. Today we're going to be looking at a review of 10.1 to 10.3. So let's think about our angles here. So anytime we've got an angle in the center of a circle, we call that a central angle. And what do I know about all of my arcs in a circle? If I add up all these arcs, what is that whole circle going to add up to? It's got to be 360. So what's nice is they gave me here the arc measure. They're just asking me for the central angle. And I know these have got to be the same if it's a central angle. So this is just going to be 120. Same thing here, 123, arc 123. All right, so things you should always be looking out for here. I've got diameters. And what does a diameter intercept? What measure does that straight angle have? Or what measure does this arc have if it's cut by a diameter? So why don't you guys try 3 and 4, pause the video, and then you can check back in and see how it went. All right, so they want us to find angle MIJ. And let's think still about that, let's think about that diameter here. So this whole arc has got to be 180, which means that this part over here is just the leftover piece from 180. So it's got to add with 55 to get 180, which means this must be 125 degrees. All right. Now this, again, this means arc. So they want us to find the measure of arc C. We got to go around to F. Then we got to go around to D. Okay. So let's see, what is this right here? What is CF? Well, that's got to be a diameter. It's a chord. It goes through the center. It's a straight line. So if that's a diameter, then this must be 180, like we saw over here. We've got 81, but I need this piece, which is, incidentally vertical to that angle, or we can look at another diameter. We can look at this diameter, and we can say, what is going to add with 135 to get me 180? So this has to be 45. All right, now let's check this out. How can we use this information to help us solve for the arc measure? I've got 180 on this side. Here's 180 plus the 45 plus another 81. So plus 45 plus 81 gets me that whole arc. So let's see, 180 plus 45 plus 81 gets me 306 degrees. All right, now we're back into tangents. And what do I know about these tangents? They're coming from the same point, going to the same circle. So what can I do with these two tangent lines, these two measures? Well, they're from the same point to the same circle. These two measures have got to be the same. They've got to be equal. So 5x plus 7 must be the same as 4x plus 15. And then 1x must be 8, or x must be 8. And then here, don't let this 18.4 freak you out. These are still tangents to the same circle. So we'll do the same process. So 11x plus 2 equals 12x. Again, don't worry about that 18.4. Just extra piece of information you don't need. And then here, x must be 2. So why don't you guys try 7 and 8, pause the video, and then see how those go for you. Unpause and check your work. All right, so 7, again, this doesn't matter, and this won't matter in 8. So we got 2x plus 10 equals 4x minus 10. So 2x equals 20 if I subtract the 2x and add the 10 to the other side. So x is 10. And last but not least, negative 6 plus 7x equals 5x plus 10. If I add the 6 and subtract the 5x, I'll get 2x equals 16, where x equals 8. So again, here I just added the 6, subtracted 5x, okay. Now, we've got to think about, again, what relationship does a tangent line have to a radius at that point of tangency A? Here we can see the same thing. Got a radius and a tangent line. And then what relationship, what angle is here? Well, it should be a right angle. But how do I check that? How do I check if 3 numbers make up a right triangle? What theorem could I use? Or what formula? Well, I can always use my Pythagorean theorem. But the most important thing here, well, I guess 2 important things, is make sure you've got the whole side length, and make sure you know what your hypotenuse is. So if CD is 20, AC must be 20. So I've got 40 squared plus 48 squared, and is that equal to 60 squared? Not really sure. Well, let's try it out. Let's see, if I do 40 squared plus 48 squared, I get 3904. And is that equal to 60 squared? It's not. So this is not tangent. It's close, definitely close, but AB is not a tangent line. So AB, definitely not tangent to the circle. Okay, why don't you guys try 10, pause the video, and then see how it went. And we'll talk about 11 and 12. So most important thing here is you got to find the part inside the circle. But what is this part inside the circle? It's a radius. Doesn't matter where I put the radius. Could draw it anywhere I want. This must be the same as any other radius. So I've got (16, 12, and 20. Let's see, is 12 squared plus 16 squared equal to 20 squared? Is 144 plus 256 equal to 400? And it definitely is. So that's great news. So I know that yes, AB is a tangent to the circle. Now, in a similar way as to how we solved 10, where we had to look for, 12 and 8, or 12 plus 8 for my hypotenuse, we've got to think about what is my whole hypotenuse here. If R was 5, what would the whole hypotenuse be? Well, it would be 21. And how would we get that? We would just add the 5 plus 16. But for now, we don't know what R is. We're trying to solve for R. So what we'll say is that whole hypotenuse must be R plus 16. So we've got 24 squared plus R squared equals R plus 16 squared. And now this is where we've got to, double distribute or FOIL out the R plus 16. So squaring a number just means multiply it by itself. Take our first product, R squared, outer products, a positive 16R, inner products, positive 16R, and the last product here, 256. Let me do this in blue now. So we've got 24 squared plus R squared equals R squared plus 32R plus 256. Again, I just combine these like terms here. Now let's look for some like terms that we've got. Well, I've got an R squared and an R squared. So I can take and subtract R squared from both sides. And you know what? Let's simplify that 24 squared while we're at it. 576 equals 32R plus 256. And if I subtract the 256, then 320 equals 32R. R must be 10. Why don't you guys set up the next one here? Be very careful though. First step you want to do is make sure you've got your R plus whatever for the hypotenuse. And then don't forget to FOIL to simplify that right side. So let's check this out. What's my hypotenuse here? It's 6 plus r. So r squared plus 9 squared equals 6 plus r squared. So let's do 6 plus r times 6 plus r. First product, 36. So FOIL first, outer, and that's not right. Outer, inner, another positive 6r, and the last is just r squared. So I've got r squared plus 81, 9 squared is 81, equals 36 plus, and again, just let me combine those like terms. 12r plus r squared. And now let's look for some like terms to combine. I've got an r squared on this side, r squared on that side. So if I subtract the r squareds, I've got 81 equals 36 plus 12 r. If I subtract 36, 45 equals 12r. So r is 3.75. And now, why don't you guys try 13 on your own? That's just like what we did at the very beginning of this lesson, looking for those arc measures, just adding those up. Make sure you go in alphabetical order, especially for B. So was it GE? So GE, add those up. 40 plus 80 is 120. Now let's do GEF. That's 40 plus 80 is 120. Plus 110 is 230. And now for GF, this is saying go the other way. So the yellow part is 230. What makes up the rest of this circle? What goes with 230 to make up a whole circle? So 360 minus 230 gets me 130 degrees. All right, now let's look at this last one here. Anytime I've got that diameter, like US, cutting a chord in half, anytime it cuts a chord in half, it must be a right angle, or anytime it's at a right angle, it must cut the chord in half. So if this is 40, then what's the other part? Well, it's the diameter. It's at a right angle, so it must have cut it in half. So X must be 40. Or here I've got congruent chords. So if the chords are congruent, then what do I know about these two arcs they intercept? Well, if the chords are the same, then so must these arcs be the same. So 4x equals 3x plus 22. Or x is 22. Why don't you guys try those last two? So pause the video, try the last two, and then we will talk about our last set of problems. So 5x minus 6 must be the same as 2x plus 9 because ln is a diameter, cuts it at a right angle. So it must be a bisector. So 3x must be 15, x equals 5. Now here we can see congruent chords. So the arcs they intercept must be congruent. They must be equidistant from the center, which means that 4x plus 3 must equal 7x minus 6. Or 3x must equal 9, or x is 3. Now keep this idea in mind. Keep that x in mind. X is still 3. We're going to use the same circle in number 18. But here we're going to find the radius. So what you want to do is you want to draw in a radius. If x is 3, then this must be 4 times 3 is 12, plus 3 is 15. And if this is through the center, if it's cutting that chord at a right angle, then how must it cut the chord? You know, what do I know about the two sides here? Well, this must be 8. This must be 8. And now I want to find the radius. So, you know, let me draw this over here. So 8, 15. What is the radius? So right angle, 8 squared plus 15 squared equals the radius squared, or c squared. So 225 plus 64 is 289. So c squared is 289. So we can take the square root. C must be 17. So I've got a radius of 17. And you know what? Let's say that let's say this whole thing here, up here, MP is, let's say that's 10 for the whole thing. Why don't you guys find your radius? So pause for a second and find that radius. All right, so if the whole thing is 10, we cut it in half. Each part must be 5. You know, let's say this part is 10. So 10, and let's plug in 5 for x. (25 minus 6 is 19. Why don't you guys find your radius here? So I want you to find your radius up here. So 10 squared plus 19 squared. So c squared equals 10 squared plus 19 squared. 461. Now we find the square root. So c is about 21.47. approximately. Now check out 19. Is AB a diameter? Well, what do we know about how does a perpendicular diameter cut the chord? So, you know, over here, how is this chord cut by the perpendicular line through the middle? So we're given 3 and this length ED, which I don't know. But how could I find ED? How in the world could I find that side length? Given my right angle, what kind of shape is this? Well, I could use Pythagorean theorem and say 3 squared plus x squared equals 5 squared, or 9 plus x squared is 25, x squared is 16, x is 4. So then we've got to ask ourselves, did it cut it into equal parts? And it definitely did not. All right, so here are some extra challenge problems. So in the figure, we've got, you know, all these tangent lines. And what do I know about tangent lines from the same point to the same circle? Well, they've got to be the same. So 2y plus 9 must be 15. 2y must be 6. Y is 3. So they want me to find QS. But I know these must be the same. So you know what? Let's find QU instead. So 15 plus 4y, or 15 plus 4 times 3, 15 plus 12 is 27. And the reason why I found QU is because I know these two tangents must be congruent. They must be the same measure because they come from the same point and go to the same circle. All right, why don't you guys find X and then find GH. Or sorry, find Y and then find GH. 2y plus 5 equals y plus 13. Y equals 8. So as always, let me know what problems you want to go over and then how I can